This next part is about solving for the absolute value. I want to begin with looking to add an absolute value that is greater. If the absolute value is greater, then I'm looking at greater than the positive going to the right and less than negative going to the left, and eventually that's what my graph should look like. So here I'm going to set this up. I have 3x minus 1 greater than or equal to 9. It's greater, so it's an or statement, and it's 3x minus 1 less than or equal to negative 9. It's greater than the positive or greater less than the negative. And then you solve for each one. I'm going to add 1 to both sides. That's 10. X is greater than or equal to 10 thirds. Here, add 1 to both sides, and that's less than or equal to negative 8. So x is less than or equal to negative 8 thirds. From here, we can graph on the number line the two values. Remember that you want to put the smaller number on the left and the larger number on the right. That's kind of important there. I'm going to group that back together. This is 10 thirds. All right, so the smaller number on the left, the greater number on the right. You have to watch that whenever you solve. I have equal to, that tells me I have a bracket. Greater goes to the right, less equal to, again, the bracket goes to the left. Greater to the right, less to the left. So this is my graph with a reminder that negative infinity is down to the left and positive infinity is up toward the right. When I write my answers, I'm going to write them two ways. The first is in set notation with go wiggly lines. So I have all values of x such that, and I'm going to write both of these answers here. X is less than or equal to negative 8 thirds, or x is greater than or equal to 10 thirds. Again, I'm keeping those go wiggly lines. For the interval notation, this is kind of writing it in shorthand, and I look at the graph. It starts down here at negative infinity, and negative infinity gets a parenthesis because it never touches negative infinity. It goes up to negative 8 thirds, and we already established that that got a bracket. Union. With the or statement, it has a union, and I'm going to merge those two sections. Pick back up at 10 thirds, go all the way to positive infinity, and positive infinity gets a bracket. So this is a set interval notation for this particular problem. The next one is a less than problem. If it's less than, it's sitting between the positive number and the negative number. In this case, it's positive 12 and negative 12. To solve this, I'm going to pull this over a little bit. To solve this, you're just going to simply pull this out. 7x minus 3 is less than the positive, greater than the negative. And you have to kind of be careful because when I read it from this direction, it does say greater than. But the symbols are both less than, less than. The easiest thing to remember is once you start with the less than, everything else becomes less than all the way through your problem. Then you're going to solve it. Add 3 to all 3 sides of this problem. And you have negative 9 is less than or equal to 7x, because this is going to cancel, which is less than or equal to 15. Again, solving, you're going to divide everything by the coefficient 7. And your final answer is negative 9 sevenths, less than or equal to x, which is less than or equal to 15 sevenths. I like these because when I'm looking at my answer, I'm looking at all my answers. On the number line, it's real simple. If I have less than, my smaller number is already on the left. I don't have to worry about that confusion. My larger number is already on the right. I'm still good there. In this case, again, both of these have equal to, so they're brackets. But where I shade, where is x? It's sitting in the middle. So all my shading is also in the middle, in between those two numbers, just like it's sitting. They both have brackets, and they face the shading. They face each other in this case. So this is my number line right here. That makes my set and interval notation very easy to write. The set notation is, again, with set squiggly lines, all values of x such that, and it's just right here the way that that answer is written. Negative 9 sevenths is less than or equal to x, which is less than or equal to 15 sevenths. The interval notation looks just like the number line. It's just graphed that way. The bracket is on negative 9 sevenths, and it goes up to 15 seconds. So to graph, the set interval notation looks a lot like the number line and the answer. So if you can get accustomed to how to bring this out of this problem, just bring it down and keep the less than, this is probably the easier type of inequality to solve for.